Decision tree is a machine learning algorithm in data science that comes under supervised classification technique. It is highly intuitive model as it is one of those models on which we can actually understand how the model is working internally. So for this, I'll show you the example under which only you itself can determine how the decision tree would be made for this. Okay, now let's consider if else for this kind of data set. So if you see this data set for a moment, you will see that here, according to the occupation, we can see all the students are having PUBG as a suggestion, whereas programmers will have either GitHub or WhatsApp. And now we can see that, oh, females are usually having GitHub, female programmers are usually having GitHub suggestion, whereas male programmers are having WhatsApp suggestion. So for this, if we make a simple if-else statement, it would look like this. See, occupation of student, PUBG, else gender female, GitHub, else WhatsApp. So for this, how could we build a decision tree for this? Let's check it out in next slide, which is C. We have first a root decision node, which is the occupation student? Yes, PUBG. No. Then the second decision node is the gender female? Yes, GitHub. No, WhatsApp. So this is why our decision tree is highly intuitive. You can see we can grasp the internal working of decision tree. This is the way that all the decision trees are being made using if-else statement. That's it. So for numerical data, as this would be our case study too, we can see for petal length and the sepal length, we are describing if the given a type is setosa or versicolor or virginica. So here is the terminology. The first decision node is usually known as root node, and after that we have arrows that split in yes and no or any kind of classification. Here we have used binary classification, so yes and no is there. So splitting is done. So in splitting, first the setosa we have as a leaf node, and another decision node is for the sepal length. Less than 1.5, then leaf node would be versicolor. If no, then it is going to virginica. Now let's see how we will create a geometric intuition for this. As we know that if petal length is less than 2.0, then it is setosa flowers. So we can see that there is a red line being drawn for the description, and all the points that are on the leftmost side of the red line are setosa flowers, and rightmost would be virginica or would be the other one. So now see, we had the another condition for sepal length. You can see now the blue line is there, and all the data points that are below blue line and after or in the right side of 2.0 petal length, it would all come under versicolor. If it is above, then it would be come under virginica. What would be the pseudocode? Begin with your data set, which would have some feature variables and classification or regression output. Determine the best feature as a second step in this data set to split the data on. More on, we would define that what is the best feature later. Now the step 3 would be splitting the data set into subset that contains the correct values for the best feature. This splitting basically defines the node on the tree, that is, each node is splitting point based on the certain feature from our data. Now recursively generate new tree nodes by using the dataset of data created from step 3. For defining our best attribute, we need two variables, that is entropy, and with the help of entropy we'll try to define our information gain. Feature with highest information gain will be our best feature. Now, to have the information gain, we first need to know about entropy. So entropy, in the most layman term, entropy is nothing but the measure of disorder, or you can also call it as measure of impurity or the measure of certainty. So if we have the example of ice, water or vapor, the entropy of vapor would be highest and the entropy of the ice would be lowest. Here, how can we calculate the entropy? Entropy have this simple formula of yes log 2 probability of yes minus probability of no log 2 probability of no. So for us, dataset 1 is more feasible as compared to dataset 2. Now, using this entropy, how can we calculate our information gain? Information gain is a matrix used to train decision trees. Specifically, this matrix measures the quality of the split. Calculate the information gain. It is entropy of parent minus weighted average entropy of children. So we would calculate here entropy of the parent, that is entropy of whole data set, and that is 9.4. So here, after calculating that entropy, I have done splitting of data. After splitting the data with overlook, sunny, overcast, rain, it has given 0.97, 0 and 0.97 as the entropy of child. So the calculated weighted entropy of children would be again calculated, that is 0.69. Here we can see the information gain is 0.28. So the information gain when you split the data of outlook column is 0.28. Similarly, now calculate the information gain of all the columns. Whichever column has highest information gain, the algorithm will select that column to split the data. Now, step 6 would be finding the information gain recursively. Once the leaf node is reached to entropy 0, no more splitting is done. So at that level, we have our decision tree completed. Now, let's take one case study, that is of iris dataset. You can see the head, it has 4 features as an input and 1 feature of species as output. So I have separated the input and output column here, and after that I have used train test split. Note that train test split is from sklearn model selection, and there it is as a class of train test split. I have used train test split for the x and y. Now for training, from sklearn.tree module, I'll import decision tree classifier. Here I have made object of the decision tree. Here I have used the classifier .fit to fit or to start the training. So training would be on X train and Y train, as I have already discussed. And here my model has been created. For prediction, I have called the classifier object with .predict method, and here I have passed the X test. For measuring the accuracy, I have imported from sklearn matrix, and matrix.accuracy score function here predicts that my model is 89.47% accurate. So this is the nice accuracy to start with. Here, as I have shown, that the maximum depth of my decision tree classifier would be 2. So if I visualize the model, you guys can see that the depth is 2. One is for the petal width and one is for the petal length.